All right, good morning. So today's topic is something called char and strings in Java. So the first thing I'm going to talk about is this data type called char, and this is a pretty big difference between Python and Java. So Python does not have a corresponding type to char. Okay, so we've talked briefly about strings in Java, right? So anything between double quotes in Java is what's called a string literal, right? So it's a string that you can write down. It's just a sequence of characters, right? Now, when I say it's a sequence of characters, what I really mean is it's a sequence of this thing called char. Right? And so Java has this primitive type, begins with a lowercase c, and it's called char. So a string is made up of 0 or more char elements. Right? So here I've got the string s, right? It's the string rub-a-dub-dub. So it's a sequence of 1, 2, 3, 4, 5, 6, 10, 11, 14. So it's a sequence of 14 characters. Right? And you're able to retrieve, it's a sequence. So it's similar to a Python sequence. You can access the individual elements of the sequence using an integer index. So here I'm using the method char at, and then passing in an index. And that gives me back a single character of the string. Right? And so I can store one character of a string in a variable of type char. You can also write down individual characters as literals. Right? So again, any single character that you can write down. Right? So you denote a char literal using single quotes. Right? So you have to make sure not to confuse single quotes and double quotes in Java. Right? Single quotes, double quotes, triple quotes, it doesn't matter in Python. In Java, if you use single quotes, you mean one thing. If you use double quotes, you mean a different thing. Right? So single quotes denote char literals. And there has to be exactly one character inside the quotes. Right? So there's no such thing, for example, as the empty character. Right? There's an empty string, right? A string made up of 0 characters, but there is no empty character. Right? Just like there's no empty int, there's no empty double. So you can have the char a. I can store that in a variable called c. Right? I can have the space, right? One space, and I can store that in this the variable named blank. Right? What I can't do is I can't write single quote, and try to store that as a char. That doesn't work. Right? So no such thing as the empty char. Chars are a bit odd in the C-like languages. So that includes Java, C, C++. So char is actually just an integer, right? It's weird, right? That a does not look like an integer, right? But as far as the language is concerned, it's just an integer of some type, right? So what the language does is it takes the integer and maps it to a corresponding character, right? And the mapping is defined by this thing called Unicode. Right? It's actually the same. It's a similar standard to what Python uses. Python also uses Unicode. I don't know if Python uses the exact same version of Unicode. Right? But in Python, the individual elements of a string are all Unicode characters. Right? And the same is true in Java. So if characters are just integer values, that means they have the same limitations that other integer values have in the Java language. Right? There's a minimum value, there's a maximum value. So the class that corresponds to char is confusingly not called big C char. Right? It's called big C character. Right? So big C character dot min value, that stores the smallest char value. And big C character max value, that stores the largest char value. Right? As an integer value, that's actually 0. And the max value is actually 65,535. Right? Don't memorize those values. But if you go to print them, notice I have to do something, I'm doing something strange here. Right? So when I print them, I'm actually casting the char values to int to get their numeric values. So let's look at this example in Eclipse, for example. Right? You can type this into a notebook as well. Right? So here's I just copied a bunch of the, oh, hang on, hopefully it didn't crash. My Eclipse may have crashed. Hello? Oh, no, it's back. Okay. There we go. Okay, so I just copied a bunch of these examples into a class that I made in Eclipse, right? I copied this example into the method called ex1, so example 1. So this is the exact same code that's on the slide. I'm going to print out the minimum and maximum values of the character type, right? So to run that method, I'm going to write a little main method, right? In the main method, I'm going to call my ex1 method like that. So I'm going to run my program. Up here. And you see that it prints out the value 0 and 65,535. Right? So the comments are accurate. Now, if I take away the int, the cast to int, right? So if I just print out character min value and character max value, you get something completely different. What's it complaining about? Oh, it's fine. Right? So when I print out character min value and character max value, I get what appears to be a blank and then a question mark. Right? And so what's happening here is that the way printline works is it looks at the type of the thing that you're asking it to print. Right? And so here it sees that there's a char value that you're asking it to print, so it prints out the text that it generates. It tries to print it as a char. Right? Now remember, every char value is mapped to a printable value. Right? So it turns out 0 is what's called a non-printing character. 0 corresponds to what's called the null character. Right? So it doesn't print out anything. Max value is 65,535. On my version of Eclipse, it prints out a question mark. But that actually corresponds to some symbolic character. I don't know what it actually is. So when Eclipse tries to print it, it prints out a question mark. Right? If you want the integer values corresponding to min value and max value, you need to cast them to int. Right? So let me just cast one of them to int. Right? And now you get the 0. Right? And if I cast the second one to int, you get the 65,535. Right? So the way printline works is it looks at the type that's passed as the argument. Right? If you ask it to print it as an int, it prints it as an int. If you ask it to print it as a char, it tries to print it as a char. Okay, so just to convince you that characters are in fact just integer values, right? I can write the integer value 65 and store that in a char C. Right? When I print C, it actually prints out capital A. Right? So it tries to print C as though it were a char. Right? So it turns out the value 65 corresponds to capital A. Right? If I print it as an int, I get the 65. Right? Normally when you print a char, you want to print it as a char, right? Not as an integer value. Notice that I can take C and I can write plus equals 25. If you haven't seen plus equals before, that operator means, so conceptually what it means is C is equal to C plus 25, right? So add whatever that value is to C, right? Changing the value of C. If I print that, not surprisingly, or yes, perhaps not surprisingly, you get the Z. Right? So A corresponds to the integer value 65. If I add 25 to the character C, right, I end up at the character Z, which sort of makes sense, right? 25 characters after capital A kind of makes sense that it's the capital Z. Right? If you want to, you can look up exactly how your keyboard characters are mapped onto the integer values. Right? If you want to, you can find out what all of the character values are, right? What all 65,000 character values are. Okay, so characters, they're just integer values. Right? And that means you can do arithmetic with them, which I just showed you. Right? You should probably avoid doing this because the results are unintuitive, especially to programmers new to Java or the C-like languages. right? Especially when you are trying to do arithmetic and integer values are involved. Because you have to know all of the rules for all of the various operators to actually figure out exactly what's going to happen. Right? So I'm going to do what looks like something similar to the previous example. Right? I'm going to start with the letter A. Right? I'm going to write C++. Right? So plus means add 1 to the value C. Right? It also means something else, but I'll leave out the something else for now. Right? So that adds 1 to C. If you were to print out the value of C, you would get the uppercase B. Right? So if you print out the value now after this line here, right, you get the uppercase B. Right? Plus equals 1 means take the value of C and add 1 to it. Right? So similar meaning as plus plus, right? Different operator. Right? So notice these are two different operators. So they actually have two slightly two different meanings in the language. Right? If I was to print out the value of C here, you would get the uppercase C. Right? Start with the A, add 1, you get the B, add 1, you get the C. Right? Minus equals is C. Conceptually, what it means is C equals C minus 1. Right? So take this value and subtract that from C and assign that to C. Right? So that'll give you back to the uppercase B. Right? Now look, I told you that means add 1 to C. I told you that means add 1 to C. Right? So if you try to write C equals C plus 1, that doesn't work. Right? And you get some funny error. Right? So let's look at the example here. Okay. So here's the code from that lecture slide there. Right? Start with the A, write C++. That works. Right? Or at least the compiler's happy with it. Right? Plus equals 1 works. Minus equals 1 works. Notice on the next line, there's a red X. Right? And it's underlined in red. Hover over the error. And it says, if you can't read it, type mismatch cannot convert from int to char. Right? So like I said, arithmetic with the char type is unusual. So what's happening is the following. Whenever Java sees an arithmetic expression, it looks at the type of the operands to determine how will it compute the value. Right? So it says that it sees that there's a C here, right? And it knows that the type of C is char, right? And it sees a 1, and so remember what the type of 1 is, it's int, right? So you have a char plus an int, right? And it turns out that char and int, they hold values having different ranges, right? Char has a much smaller range than int, right? So to compute C plus 1, Java says, well, I have to convert the smaller type to the larger type. So it converts the char to int, right? And does this as int arithmetic, right? And so the value of that, remember what the value of two, if you do arithmetic with 2 int values, you always get back another int value, right? And so C plus 1, its type is int. Int is a bigger type than char, so the language won't let you store a wider type or a larger type into a narrower type or into a smaller integer type. So it won't let you store a larger integer type into a smaller integer type. Right? Int is bigger than char, so you can't put int into a char variable. You can't put an int value into a char variable, so that's why that doesn't work. Right? But it's extremely confusing when you see this because that works, and suddenly this does not work. Right? And it gets worse. Right? I can take another char, the character B, right? And now I can write C plus D, or try to write C plus D. Right? So you use the rules that I just told you. Right? What's the type of C? Well, it's char. What's the type of D? Well, it's char. So when you write C plus D, you would think you get a char value, but you don't. So this doesn't work in Java either. Right? So there's another rule I haven't told you about. If you try to do arithmetic with integers, and the integer type is smaller than int, it always gets converted to int. Right? So this, even though they're both of type char, C and D both get promoted to int, so they both get converted to ints. The arithmetic happens as int, and now you're back in the same situation. You cannot store an int value in a char value. Right? Why does it work that way? Because that's the way the language was defined. Right? If you try to do arithmetic with char, byte, or short, you end up with int arithmetic. Unless you use plus plus or plus equals or minus equals. Those all work, right? But as soon as you try to use just regular plus or regular minus, suddenly it falls apart, right? So yes, this is possible, but you have to be very careful when you do it because the rules are very confusing. Is there a question? Yeah. If I change the type of oh, e, yeah, down here. If I write int e equals c plus d, yes, that works. But it's not a char anymore, right? It's not a char anymore. If you really want to compute these this way, you need a cast, right? So I can fix this, right? So the error is all of that is an int, right? I can force the compiler to treat that as a char by casting the result. So I compute that result, and then I tell the compiler, hey, that's actually a char, right? And now notice that the x goes away, right? And the underline goes away now, right? So that's fine. Similarly here, right, I can compute the result. So that gets computed as int, and then I can tell the compiler, hey, I really want that to be a char, right? And now it's okay. If you printed out E, what did you get? A plus B, so that's A plus 2. No, oh wait, actually that's going to give you something weird. Yeah, so the result is unintuitive as well. System out print line E. Right? So that's going to try to do big A plus big B, which is going to give you some funny value. So let me comment out the original one. All right, so what's the value of E? Apparently the value of E is question mark, right? I don't know if it's the actual question mark or if it's just a character that it can't print out, but it's something, right? So again, the results are unintuitive, so you have to be a little bit careful when you do this. Okay, now, so when would you want to do this, right? So this arithmetic with char is occasionally useful. Right? So there are some occasions where you want to algorithmically generate a sequence of characters. For example, I might want to generate all pairs of 2-letter uppercase strings. So AA, AB, AC, all the way through ZZ. Right? And so you can do this using char arithmetic. Right? So C starts at big A, right? Goes up to and including big Z. Right? Each time through the loop, I'm going to advance or increase the value of C by 1. So A, B, C, E, all the way through Z. Right? I can use a nested loop that does the same thing, this time with the character D. Right? So again, starting at A, going through to uppercase Z. Right? And now I can join the two characters together using string concatenation. Right? So I can make the string made up of the two characters C and D. Right? So the way you do that is you start with the empty string, right? Add C and add D. Right? So remember, in this context, the plus operator is string concatenation. Right? Start with a string, plus anything, that gives you back a string. Right? So that will form the sequence big A, double AA through double ZZ. Right? So that's example 3 here. And I can call that by typing in name of the class, .ex3. Right? And when you run that, you get the sequence, well, there's the ZZ at the end. The AA is probably, oh, there it is, all the way at the top. Right? So if you ever want to generate a sequence of strings that are similar to this, it's possible, it's sometimes possible to do using char arithmetic. I guess the other thing I should point out is the following. So notice that when I call the method, right, so when I call ex3, I'm using the name of the class and then a dot and then ex3, right, round bracket because I'm calling a method. Right? But this main method is in the same class as ex3, right? They're both in the same class. So if you leave off the name of the class, right, everything works just fine. Right? So in other words, if you have a method in the same class, you don't need the name of the class to call the method. Right? You can just call it with the name of the method. Right? So this also works, ex2 and ex1 will also work here. Right? If you run the class, everything's fine. Right? So if you're trying to call the static method from inside the same class, you don't have to you don't have to write the class name every time. Nope, sorry. Okay, so I'm going to talk about string, but before I get to string, I have to tell you about what is a class and what is an object. Right? And to start all that, first of all, I'm going to tell you what is a type. Right? So a type is a set of values and the operations that can be done with those values. So in Java, the int type is the set of values integer min value through integer max value. Right? What are the operations? Well, I can do addition, subtraction. I can do arithmetic, right? I can compare them, less than, greater than. And you can do a few other things with them as well. Right? Okay, so what's a class in Java? So we've made some classes, right? But we don't really know what a class is, right? Right now, all you know is that if I want to make a program, I need a class. So what a class is in Java is that it defines a reference type in Java. Right? There's no way for the programmer to define a new primitive type. Right? Only the people who made the Java language could do that. Right? But you can make your own reference type. Right? And so that's just a class. Right? So that's Java's way of letting users make new types. Right? And finally, there's this thing called an object. So an object is what's called an instance of a class. And so I'll explain that as we move along through the rest of this lecture. Okay, so there's something called the string class, right? So remember what a class is. A class is just a reference type. Right? So a string, the string class represents a sequence of text, right? And in Java, it's a sequence of char, right? Strings are very common in Java programs. Right? And because they're so widely used, the Java language is a bit weird on how it treats strings. So the Java language lets you do things with strings that you cannot do with any other type of class. Right? So for example, you've got these things called string literals, right? A sequence of characters inside double quotes, right? There are no literals for any other type of class in the language, right? So there's no way for you to write down some sequence of text and call that an instance of a class, right? So string literals exist, but literals do not exist for any other reference type. You also have the plus operator, right? So plus with strings means string concatenation, right? But there are no arithmetic or comparison operators defined for any other reference type in Java, right? So that means you cannot use plus, right, with any other reference type in Java. Yes? Yeah. Yeah.
Which has defined different cells in that for.
Is it the demo or for state demo?
The demo.
Okay.
The state square bracket itself.
Yeah.
Is that not a literal?
No, that's the name. That's the name of a constant.
What makes a literal different?
A literal is something that you could write down. So for example, you can write down the number 2, right? The equivalent here would be state dot, if you had a constant that represented the number 2. So that would be state.tow, for example, right? The TOW is not the number 2, right? It's the constant that happens to represent the number 2, right? So this is just a variable, right? Occupied is the name of a variable whose value you cannot change in this case. That's what it means here, right? So it's actually a variable. You can't change its name or its value because this is an example of an enumeration, right? But when you write down a literal, though, right, that's an actual literal value. Yeah.
So you wouldn't be able to write out an array, or instead of like 4, 3, like an array.
Sure, you can. You can do that because you can write down an int literal, right? But if you had another reference type except for string, there's no way for you to write down literals for those other reference types. You can make constants and have those constants represent something, but you're still using a variable name. It's not an actual literal. Okay, if you want to, so when you go to start to use these classes in Java, you need to know what are these classes capable of, right? So what can these things actually do? And so the Java language is nice in that there is a standardized set of documentation for the language, right? Similar to Python, but I think Java's documentation is easier to read than Python's. So if you just go on to a web browser and you Google something like Java string, and then if you pick a number for the version of Java that you're interested in, so 20, for example, this will give you information about, the first link will almost certainly be the documentation for the string class for version 20 of the language, right? If you use a version 8 or higher, it's fine, right, for this course. So here's the documentation for the string class that you end up at. Right? Part of learning how to use the language is using its library, right? And the string class is part of the Java standard library. So you have to learn how to read the documentation. The problem is at this point in the course, there's a lot of stuff in this document that you won't be able to understand, right? And so you have to accept the fact that you're just going to skip over stuff that you don't understand, right? So here you see there's the name of a class, right? You might be able to kind of figure out what that means there, package java.lang. So it looks like the class string is inside this package named java.lang. Right? There's this thing called a module, which I told you earlier in the course we're not going to use in this course, but it's in the module java.base. Right? And then you see some other stuff here. Right? You see the formal declaration of the class here. Right? So when you whoever created the string class actually wrote all of that when they for their declaration of the class. Right? We've been writing stuff like public class string, but here there's a bunch of other stuff as well. Later in the course, you'll learn what all the other stuff means. Right? And at the beginning of every document for a class, right, you'll see a description of the class. Right? And this typically goes on for a little while. Right? And so the description for the class tells you what is the purpose of the class. It tells you in brief what the class can do. Occasionally, you'll get examples, but not always. Usually, most of the time, you don't get any examples. But the description of the class is often useful to read, right? And so it tells you for the string class that it's a character string. All string literals in Java programs, such as ABC, they are actually implemented as instances of this class, right? Tells you more. Strings are constant, right? Their values cannot be changed after they are created. So this is identical to how Python strings work, right? Python strings are constant. Although using that language, it's often easy to believe that they're not. Right? And it goes on for some while. Right? If you keep on scrolling, you'll see some more information. Right? So you'll see something called the field summary. We're not interested in this right now. Right? You'll typically see something called the constructor summary. We'll be interested in this next week. Right? For now, we can just skip over it. Then you'll get to the method summary. Right? So these are all the methods that you can call using a string object, and I'll explain exactly what that means in a second. Right? So when you look at this, what you'll see here, you'll see the return type of the method. You'll see the method name and its arguments, and then you'll get a really short description of what that method does. Right? For the string class, it has a lot of methods. Right? So if I start scrolling, right, notice that there are many methods. And so it's not unusual for the standard library classes, especially for one like string, which is widely used, that it ends up having a lot of methods. Right? And part of learning the language is actually learning that these methods exist. You might not have to remember how to call them exactly, because you can always look at the documentation. Right? But you need to get a feel for what methods might exist inside of a class. Right? Inside the commonly used classes like string, you'll get, so as you use the class more and more and more, right, you'll get a handle of, you'll start to remember which methods or what capabilities does this class actually provide. Right? Now, we've been using only static methods. So if you look at most of the methods are not marked as being static. Right? Some are, though. Right? So value of, some Boolean value is marked as static. Right? So those are the methods that we're used to using right now. Right? Today we're going to use the other methods, the non-static methods. Right? And the way you use them is slightly different. All right, so string objects are immutable. Right? So what that means is once you make a string object, you cannot change the sequence of characters in that string object. Right? Now, if you look at the documentation for the class, it looks like there are methods that change the characters of a string. So if I flip back here, right, notice there's a to lowercase, right? And if you look at its description, it says converts all of the characters in this string to lowercase. So it looks like this method actually changes the characters of a string, and in fact, that's a lie. It does not. Right? So methods that look like they change the characters of a string, they don't. They return a new string object. Right? So look at to lowercase. Right? To lowercase returns a string. Right? So what to lowercase does is it takes a string, computes a new string made up of the lowercase letters of the current string, and then returns a reference to the new string. Right? It doesn't actually change the characters of the current string. Where is I missing something here? Oh, here we go. I'm going to explain that in a second. Okay, so for example, to uppercase and to lowercase. Right? They return uppercase and lowercase versions of a string. They do not modify the original string. Right? So here I've got the string literal hello. Right? I'm going to store a reference to that literal in the variable s. Right? Now I want to take s, right, the string hello. Right? You have to be careful when you think about it this way, right? So it's very natural here to think, well, s is the string hello. Right? So I want to ask the string hello to turn it to give me its uppercase version. Right? What you have to remember is when you call to uppercase, it's returning a new string. Right? So you almost certainly want that new string. So I'm going to store that in another variable called up. Right? If I print out the value of s and the value of up, I'm going to get lowercase hello and uppercase hello. So here's string example, right? So there's hello, there's up, and then I'm going to print them out. Right? I'm going to comment out this line. Okay, so let's run this. Okay, so when I print out s, I get lowercase hello, which was the original string. When I print out up, I get uppercase hello. Right? And so that line right there, right, notice that appears after the call to uppercase. Right? So that should convince you that, in fact, the string s was, in fact, never changed by the call to the method. Right? It's still lowercase hello. Right? Up is uppercase hello. Right? Now, the common error is that when you call a method like to uppercase or to lowercase, right, is that it changes the case of the string that you called the method with. Right? So that's what this s dot means here. Right? S dot means go find the variable called s. Right? Go get the string that s refers to. So in that case, it's hello. Right? Ask that string object to call its to uppercase method. So in other words, s dot means, hey, object s, please call to uppercase on yourself. Okay. So if you forget that strings are immutable, that looks like it changes the case of the string referred to by s. Right? It does not. Right? So if I call to uppercase on s and then print out s on the next line, s is still in lowercase. Right? So it doesn't actually change the case of the string. Right? It gives you back a new string where the characters have been modified from the original string. Okay, so this to uppercase and the to lowercase methods, they are non-static methods. Right? Go back to the documentation. Right? There's to lowercase, there's to uppercase. Right? Here's the return type. If there's a modifier on the method, it also appears here. There's no static here, keyword here. Value of has a static keyword. To uppercase, no static keyword, right? If a method does not have the static keyword, right, then it's just called a regular method, or in long form, it's a non-static method, but that's just a regular method, right? Static methods are actually the exception, right? To call a non-static method, you need a reference to an object, right? So here I need s to call that method, right? Any string reference here will do, right? But I need a reference to a string object, right? So when you write s.toUppercase, you're asking to, you are using the object referred to by s to call the non-static method, right? So I'm asking the object referred to by s to call its toUppercase method. Now, string has static methods as well, right? Now, remember, to call a static method, you always use the name of the class, right? So use the class name to call a static method, right? The methods called value of, they all convert some primitive type to a string, or they they give you back the string representation of some primitive type object, some primitive type value, right? So big S string dot value of, right? Big S string means this is a static method, right? Value of 1.0 gives you back the string representation of 1.0, right? Which in this case is just 1.0, right? String value of little case true will give you back the string corresponding to the Boolean value true, right? And so on and so forth, right? You can use value of. I think string concatenation is often easier to write, right? It's definitely shorter to write, right? But both of these work, right? So that's the distinction between a static method and a non-static method, right? Static method, you use the name of the class. Non-static method, you must use the name of an object, or a reference to an object, sorry. Typically the name of a variable. Okay, so a string is just a numbered sequence of, in this case, char in Java, right? So the string CISC124, right? You can think of that as a sequence of the sequence of characters big CISC124, right? Each character in the sequence gets a numeric index, right? Starting at 0 in Java. Okay, so the number of characters in a string is called its length, right? I guess that's true in Python too, right? So in Python, if you had a string, you'd write len, round brackets, name of the string variable, right? In Java, the length method belongs to, the length method, you need an object to call the length method, right? So if I have a variable called course name, it refers to the string CISC124. If I want to get the length of the string referred to by course name, it's course name dot length, round bracket, right? Because you're calling a method, right? If you go and look at the documentation and you look for the length method, right there, right? It returns the length of the string. Oh, if you click on one of the method names, it takes you to the detail of the documentation, right? So in this case, it tells you the length of the string. The length is equal to the number of Unicode code units in the string. For our purposes, that's the number of characters in the string. Right? You can have the empty string in Java, right? So the empty string is the string consisting of no characters, right? So its length is 0. You often have to deal with the empty string as a special case if you're writing string algorithms. If you want an individual character in the string, then you use char at, right? You can't use the square brackets like you can use in Python, right? So char at is like using the square brackets in Python, right? So char at returns the character at the specified index. The index is always between 0 and the length of the string minus 1 in Java. Right, so here's our string CISC124. I'm going to write a little loop that loops over the individual characters of the string. Right, so I'm going to use a counting style loop. Right, so for int I equals 0, right, so starting at the first C, as long as I is less than the length of the string, so going up to and including the last character of the string. Right, each time through the string, I'm going to make the index go up by 1. Right, I can get the character at index I and print it out, right? So if you run that, you'll get the string, you'll get the characters CISC124. right, which we can quickly do. Where'd it go? Here. Okay, so I'm just going to copy that and paste that into Eclipse as example 2. Right. And then I'm going to call example 2. And I guess I'll comment out example 1 like that. Right. So here you're going to get each character of CISC124 printed out on a line on its own. Right. So you get this. So you get out the individual characters, one line, one character per line. Okay, so here's a little method that counts the number of times a specified character appears in a string. Right? So make some class, in this case it's called strings, you can call it whatever you want. Right? The method is going to be static. Right? It's going to return the number of characters in a string. Right? It's called FREQ, short for frequency. Right? It's going to take in some string referred to by S. Right? And it's going to look for a character whose value is given by target. Right? So in other words, look for all the characters that are equal to target in the string S and count the number of those characters. Right? So this is just a counting problem. Right? It's the same as any counting problem that you'd write in Python. Right? Start with a count of 0. Write your little loop that loops over the characters of the string. Right? Now I'm going to use char at to get the individual characters of the string. Right? I'm going to look at each character and compare it to target. So the equality operator in Java is equals equals. Right? So is the character at index I equal to the target character? And if it is, add 1 to the count. Right? After you're done processing all the characters, you just return the count. Right? Now, you might ask, can I not write a for each loop over the string? And the answer is unfortunately no, you cannot. Right? That's, I would guess that's one of the annoying deficiencies of the Java language. The string class was created before the for each loop was put into the language. And the string class is also pretty fundamental to the Java language. So there was no good way to retrofit the for each loop so that it works with strings. Right? Or at least it hasn't been done yet. So if you want to loop over the characters of a string, you're stuck using the old style counting style for loop. Right? You can't use a for each loop, unfortunately. Okay, now if you wanted to use the frequency method, right? This time I'm making a separate class. Got a little main method. I'm just going to call the frequency method from another class. Right? So strings dot frequency, right? The numbers of uppercase C's in course name. Right? CISC124, there's 2 uppercase C's, so you get 2. Right? Strings are case sensitive. Right? So the number of lowercase C's is 0, and the number of 4s there is 1. Notice that that's the 4 in single quotes, not the numeric value, plain old 4. Right? The method here is expecting a char. Right? If you want to count the number of the instances of the character 4, you have to pass in the character 4, not the number 4. Right? The number 4 and the character 4 are different. Right? As the previous char examples should have shown you. Okay, so what else can strings do? So there's a lot of methods in the string class. I can't cover them all. Right? So I'm only going to cover the most commonly used ones, or what I think the most commonly used ones are. Right? Contains returns true if a substring appears inside of another string. Right? So a substring is just a sequence of characters that all appear in the same order. Right? So, does the substring CISC appear in CISC124? The answer is yes. Right? Big CISC does appear in CISC124. Right? Does lower CISC appear? The answer is no, so you get false. Right? Does the string 4 appear in CISC124? The answer is yes. Can you search for a character with contains? The answer is no, right? Another strange feature of the way the class was designed, right? You might think that the class would be designed to search for characters, right? But instead, contains searches for strings, right? So if you try to search for the character C, you get an error, It says there is no contains method that takes in a char. Right? So what do? Well, you want to pass in the string C and not the character C. Right? The easy way to convert a character to a string is just to use string concatenation. Right? Concatenate it with the empty string. Right? And so that works. This one, unfortunately, does not work. At least it didn't work in Java 8. Let me check if it works in Java 20, because I haven't looked in a long time. So if you go and look for contains, right, what you find is contains char sequence, which is also confusing because we don't know what a char sequence is. For our purposes, a char sequence is just a string. Right? So that looks for a string inside of another string. Okay, so the last method, and then we'll call it quits for the day. There's the method index of. So index of is another search method. So index of lets you search a string for a specified character. This is why contains doesn't search for a character. It's because there's a different method that searches for a character. That's index of. Right? So index of returns the index of the index of the first instance of a character in a string. If the character is not in the string, it returns -1. Right? So what is the index of the big C? Well, it's 0, because big C is the first character of the string. Right? What's the index of S? Well, it's 2. Right? What's the index of the 4? It's 7, I think? 6, right? 7 character, yeah. And what's the index of Z? It's -1, right? The character Z does not appear inside the string. Right? And we'll call it quits there and pick this up on Wednesday. Right? Assignment 2 should appear tomorrow. Remember, you do have the 7-day universal extension if you need it.